So here I'm going to teach you how to analyze exponential functions. So we're given an exponential function, and exponential functions are written in this form where you have a times b to the x. A is going to be the initial value. B is going to be what's called a growth factor, and that's going to translate into some kind of percentage that you can connect it to. And then you have X, which is your time period for whatever you're doing in terms of word problems. So we're going to determine a whole bunch of stuff from here. We're going to figure out if it's growth or decay. We're going to find the initial value, the growth factor, and the percent of change. So in this problem, we have f of x equals 4 times 0.64 to the x power. So our initial value will actually hop around a little bit. Our initial value is going to be 4. For some equations, if there's no plus or minus at the end, that's also going to be your y-intercept. Your growth decay factor is going to directly relate to whether this is exponential growth or decay. That's this base. So pretty much an exponential is saying you're starting with 4 and you're going to multiply 0.64, 64 hundredths every time. Well, 64 hundredths is less than 1. So if b, this base, right, if b is less than 1, then you have exponential decay. If you're multiplying something by, let's say, half over and over again, it's going to decay or decrease over time. If your growth factor that you multiply by is bigger than 1, let's say 3, and it's tripling, then that's when we say this is exponential growth. So once you find your growth decay factor, that is pretty much directly linked to whether it's exponential growth or decay. So this growth or decay actually also can be converted into a percentage. So this is a decay because it's less than 1, right? So if the decay factor is 0.64, we need to figure this out as a percentage. So if we make this a percent, it means it's 64%. If you are multiplying something by 64%, that means something is being decreased. Anytime you decrease in terms of percentage, you always decrease it from 100%, which is the total. So if you're decreasing it from 100%, you're pretty much doing 100% minus 64%. If you don't want to do percentages, it's 1 minus the 0.64 that's in that parentheses. So this is 36% or 0.36. That is your percent change. It is a 36% decrease. So it's not at 100%, it's at 64%, so it's a 36% change from 100. So that's how you find percent change based on your growth or decay factor. So here's another example. So we're going to rewrite this so it looks a little nicer. F of x is equal to 2 to the negative x power. Well, now we have 2 is our base, which means our a has got to be 1. we could add a one, we can multiply a 1, but we can't multiply anything else. And then our exponent is negative x, so negative 1 times x. So this is all algebraic manipulation. We have 1 times. Now this, when you multiply exponents, you can rewrite them like this or split them up. The reason this is important is because x is supposed to be a time period. X cannot be negative. Your exponent cannot be negative. We need to rearrange this. So when we rearrange this, this problem changes to 1 times 1/2 to the x power. So the negative 1 makes it a fraction. And now we have everything we need. So our initial value is going to be 1. So we're starting with 1. Our growth or decay factor, what we're multiplying by, is 1/2. That is less than 1. Since b equals 1/2, b is less than 1, so it's exponential decay. Now to find this percent change, we have to take this 1/2 and turn it into a decimal, which is 0.5. So 1 minus 0.5 is 0.5. So it's a 50% decrease. That would be your percent change. It's either a increase or a decrease. So in this case, it's a decrease. For problems where it's an increase, it's all the same deal, only that b value is going to be bigger than 1. So you take the 1 away, and it's going to show you the increase or decrease. But that's how you analyze exponential functions.